Thank you so much, everyone, for joining. Welcome to the session on cryptocurrency and blockchain. My name is Devesh Lathi, and I represent FutureWise. And you are now doing a week-long program on cryptocurrency and blockchain. FutureWise has is started to help students like you build future-ready skills. This includes skills like cryptocurrency and blockchain, robotics, AI, and other skills which are going to be relevant for the future. Yeah. And I'm sure by the end of this program, you will have a good understanding of what cryptocurrency is and what blockchain is. And very quickly, I'll just tell you the schedule of the program, and then I'll give you some rules. But before going into that, let's hear a very quick, brief introduction from the four of you, Raghav, Sia, Jia, and Dhanesh. Yeah, in the introduction, just tell which high school your name, of course, which high school you are from, which grade you are in, and any one quick interesting fact about yourself. Let me start, and then I'll pass it on to you, and then you talk about that one interesting fact. Just relax. It's a very small group, and it's by design that we have kept such a small group. So just relax. You're all um, grade 11 students, except Dhanesh. And it's just a fun interactive session. And then I'll pass it on to Vipul, who is our instructor for this program. So my name is Devesh Lati. I am the founder of FutureWise. One interesting fact of about me is I love solving puzzles, and whenever if you send me a puzzle, and even if I'm very busy, I'll definitely try and solve that first before moving on to other things in my life. So that's about me. Who wants to go next?
Yeah, me.
Go ahead, Dhanesh. Yes.
Yeah, my name is Dhanesh, and I was in Ferguson College, and I like to innovate.
Okay. What kind of innovation?
Tech innovation.
Okay. Good. We'd love to learn more in a while. Uh, Dhanesh, now pass it on to someone.
Yeah, I will pass to Raghav.
Hello, my name is Raghav Mathur. I'm in grade 11 and I study at Premier Academy, Nairobi.
Okay.
Yeah.
One fun fact, Raghav.
Maybe I like to play golf.
Oh, you play
Yeah.
golf. Oh, that's
Yeah.
great. Superb. Great. Pass it on.
I pass it on to Sia.
Sia.
Hi.
Hi, you're audible. Yes.
Okay. Hi. My name is Sia. I am studying at Belvedere British School, and my fun fact is I can play the guitar.
Okay. Wonderful. Superb. Thank you, Sia. And finally, Jia.
Hi, I'm Jia. I study at Chhatrapati Nursery School and
Okay.
I'm great at word searches.
Oh, okay. Superb. So, which, like, do you do? Which is there a magazine, or is there a newspaper, or is there a website that you use for that?
No, I just do random word searches online.
Oh, okay, cool, superb. And let me now give you a brief introduction of our speaker today, Vipul Mishra. Vipul Mishra went to IIIT Bangalore, and he's a decentralized finance analyst and a blockchain developer. He has a deep expertise in both public and private blockchain networks, and he has built and deployed multiple Web3 projects, including NFT marketplaces, DeFi contracts, and crypto trading bots. He has worked extensively with Ethereum, Hyperledger Fabric, and smart contracts, and he has led teams as both developer and CTO, the Chief Technology Officer. Vipul holds a PGP in software engineering with a focus on blockchain from IIIT Bangalore, and he brings hands-on experience in building real-world blockchain solutions. Vipul, we are thrilled to have you with us today. Thank you so much for agreeing to do this session for our students. Students, please keep your eyes and ears open, keep your cameras on. And towards the end of the session, you will get a problem statement that you will work on for a couple of days, and you will submit your statement or your response to it via a Google form. And then the deadline for that will be November 5th. And then from November 5th to November 7th, all of you will work on uh, reviewing someone else's work. Yeah. So it's called peer review. Someone else will review your work and they will give feedback to you, and then you will review someone else's work. That should happen by November 7th, and then November 9th is the final session. That's a brief overview. Without any further ado, over to you, Vipul. Looking forward.
Thank you so much, Devesh. I believe I'm audible, right? Okay. So welcome everyone. We will be now starting with the basics of blockchain class. I am going to share my screen and I believe it is now visible, right?
Yes, yes. You'll have to just reduce the size of my, or just, I think your full screen is shared. Instead of sharing the full screen, maybe you just go and like share uh,
Right.
just the specific tab. Yeah, perfect.
Great. Okay. All right. So let us start with the basic of the blockchain. So this first class basically is going to introduce to what blockchain actually is, how it functions, uh, how and when it was invented, what are the technical jargons associated with the technology, right? Now, I will just explain you, I'll just read out to you the definition, then I'll just give you some explanation. I also want to make sure that this is an interactive class. If anybody among you has a question, you can always ask the question, interrupt me and ask the question. I'll make sure that I'll answer the question. At the same time, just make sure that you do have the understanding of the basic structure, so that we can also keep it, like we will have to utilize in the kind of research you'll have to do throughout this week in order to make sure that you understand and then bring on the some sort of data that will be, Devesh said, will be reviewed by your peers. Now, first of all, what exactly is blockchain? And to answer this question, I believe most of you know what is a database. A database is basically a computer structure which stores the data. I'll give you an example of Instagram or Facebook or Amazon. If you go on Amazon, you try to buy a product, all these data about the product, the pricing, the pictures, everything is actually stored in a database. And when you go online, you try to connect to the internet goes ahead and fetches the data from the databases and it shows up on your screen. Now, there are multiple kind of database. There's a centralized database, decentralized database, distributed database, non-distributed database. Now, when we speak of blockchain is just a kind of database. And we will be specifically talking about the blockchain as a database in today's classes, and make sure that you understand how it functions on a platform which has been created by the peers of network. So there are basically a lot of computer and peer involved in the blockchain network who take care of the network and make sure that the process of blockchain is always up and running 24/7. Now, as we go with the definition, it says blockchain is a distributed ledger system. Again, a ledger is basically a record book. A record book means where a place where you sequentially write down your transaction data so that you know what transaction is first and what transaction is next. It is actually called a ledger. Now, a ledger which is distributed, it means that it is distributed among multiple peer computer or network, is called distributed ledger system. Now, a distributed ledger system again is data being shared with multiple computers. The relevance of is that if one computer loses, the data is still available with the other computers. So a distributed ledger system that securely records the transaction. When we say securely record the transaction, it means when the transaction is being written in a ledger, it has to go through some checks and validations, so that we can make sure that the transaction is not rigged and is not manipulated. is actually going in the ledger as it was initially processed. Now, there's a network of computers which basically take care of this. And when we speak of the blockchain network, you have to realize that a lot of people who voluntarily initially gets to be the part of a blockchain network, they validate the transaction, they try to validate the transaction, they keep a copy of the storage where they have the ledger system, the records of all the transaction. And when what happens is that blockchain, as I explained, is a database, and when you have a new ledger installed or put on a block, it requires certain kind of validation. And whichever computers, let's say there's 1,000 computer on a part, or on a network of a blockchain, if one computer is validating the transaction, they are rewarded in form of cryptocurrency, which again we will be talking a bit about in the later session. Now, for now, I hope you understand what a blockchain is. It's basically a record book stored among multiple computers. It is stored among multiple computers, hence it is called distributed. And since it is secure through algorithms which are very secure, it cannot be rigged or it cannot be manipulated while it is being stored on the database. Now, there's some key concept. As I said, it is distributed and decentralized in nature, the database. Now, when we speak about decentralized nature of a database in the blockchain system, you have to realize, you have to actually understand that there are other databases, and I'll give you the example of banking, so the airports. Now, let's say that you are banking with your bank and you deposit some money and then you withdraw some money. All these transactions are actually saved in the banking database, and these databases are only available to the bank. Nobody else other than the bank can actually have access to these databases. Now, this is actually called a centralized database. Now, at some point of time, if the bank loses the data from their servers, everything will be disappeared, right? Hence, actually it is very safe. It is very difficult for a banking server to be rigged, but it still has a risk that if the central server is attacked, or if the data is erased in some sort of cyber attack, the data with the bank will always be erased. So that is the centralized nature of the database. Similarly, with the airport, if you go to an airport, they do have multiple servers, they do have decentralized servers, but it is again connected to one main server, and if one main server is attacked, they lose all of the data. So when we talk about decentralized database, it means that it is not centralized to one server. And in case of blockchain, as I told you, that multiple computers are a part of a network of blockchain, the data is stored on each of these computers individually, and even if one of these server or the computer loses the data, it can always be fetched from the other computers in the network, right? And when we speak about distributed just means that it is distributed among the peers, so that when you have a new transaction taking place on the blockchain, the transaction will be quickly, there are some protocols and algorithms through which it will be quickly distributed among the peers of the blockchain network, and the transaction will within no time will be available with all these decentralized computers that are taking care of the storage of these data, right? So this is what the distributed and decentralized nature of the Bitcoin, or the blockchain is. Now, as I told you, that when we store the data or store the transactions onto a blockchain network, we have to make sure that it is not rigged, it is not being manipulated. There's no external virus, or there's no external cyber attack which is changing the data, because it can cost a lot of money, because most of these things are included with the cryptocurrency transaction. So it means that money are being exchanged, and the data manipulation can cost a lot of individuals or the companies a lot of money. So in order to verify these transactions, we use some cryptographic hashing algorithms, and then we chain the blocks where we are storing the data with those cryptographic algorithms, in order to make sure that even if one single point of data changes, the entire block data will be changed, and the validators of the transaction, which are again the miners in the network, the computers in the network, they will realize that there's somebody trying to change the data, or trying to change the transaction, then they will not validate that transaction, it will be reversed. So we basically use certain cryptographic hashing. Some of the algorithms are known as SHA-256 or SHA-512. We will be talking about these algorithms later in this presentation. Now, one more important part is the consensus mechanism. Now, as we were talking about, that the blockchain include a lot of computers, a lot of people who come together. They basically agree upon a set of rules which will be running that network, and those set of rules are basically the consensus mechanism. Now, there are multiple kind of consensus mechanism, and if we take some example, we have the most famous cryptocurrency is Bitcoin. Bitcoin is basically a cryptocurrency for the Bitcoin blockchain network, and Bitcoin blockchain network use the consensus mechanism, which is called POW. Now, POW, which is again, it is called proof of work. The full form, the proof of work is a consensus mechanism where all the computers try to just hit one random number, and whichever computer hits that number will be able to validate that transaction. Now, we will be getting more upon that. We will be talking about the consensus mechanism in detail in the next class. Before, what you need to know that there are several kind of consensus mechanism which allows these different computer to agree upon certain set of rules, and then they can function according to the rule in order to validate the transaction, or in order to make sure who is mining the transaction, who's getting the reward, what time it takes to block a mine a block it, what kind of money they receive in terms of cryptocurrency, whether they receive less amount, whether it depends on the time it takes for them to mine a transaction, validate a transaction. All these details are inbuilt in the consensus mechanism. We can discuss this in the further class. Now, again, it is immutable in nature. What immutable it means that once a data is stored on a blockchain, it cannot be changed, right? It is you can put a new data, you can edit new data, you can edit the data which is already available on the blockchain, then put it on a new blockchain, then attach it. But the previous data is always going to be available on the blockchain as it is. It cannot be tampered. Blockchain does not allow the edit option to the already blocked or the mined data which is there on the network, and hence it is tamper evident, because if you already have a data which cannot be changed, it cannot be tampered. And this is very much this is very useful in the cases of land records. Now, we have to realize that many of the states and the countries are going ahead and they're keeping the land records on the blockchain network. So at any point of time, you have to review at certain point of time in which year who owned that land. They will be able to just go through the data and will realize that this and this party was the owner of the land, and whatever other details are available with the blockchain data, right? So it is very important, and this is one of the most important things with the blockchain, that it cannot be changed. Once the information is put on a block, it cannot be tampered, it cannot be changed or edited. Now, let's just talk about the origin of blockchain. I will just read the document. It speaks of itself. The concept of blockchain was introduced in 2008 by an anonymous person or group under the pseudonym Satoshi Nakamoto. This person, Satoshi Nakamoto, he just introduced the algorithm. Now, the blockchain is actually the combination of a lot of things. It is a combination of the digital hashing. It is the combination of digital signatures. Now, digital signature means how you identify yourself on a computing network. Now, let's say all of you have a computer right now. Now, how do you make that computer a part of the blockchain network and be a peer and try to then take part in mining of a blockchain and do all those things? So it requires a digital signature. So there were already the concepts of digital signature, the cryptography hashing, which secures a transaction, and the consensus mechanism, POW, POS, all these things were already there. But what Satoshi Nakamoto did, he used all of these different tools and techniques and technologies in order to bring the concept of blockchain. He wrote the paper in 2008. It was published in 2008, and in 2009 he used the same blockchain network to introduce the Bitcoin network. It is again the network which was the first blockchain network introduced to the world. It had its own cryptocurrency, which we all know is the most famous cryptocurrency by date, known as Bitcoin. The original goal was to create a peer-to-peer electronic cash system that removed the need for the banks or the intermediaries. Since then, blockchain has evolved beyond cryptocurrency into diverse applications, including smart contract, decentralized finance, supply chain tracking, and digital identity management. Right now, initially, when Bitcoin was introduced by Satoshi Nakamoto, his sole purpose was to introduce it in a way that the dependence on the banks will be reduced. There will be an easy access for the people living in different countries to transact. They will be able to send a currency in order to buy some goods, or basically just if they want to transfer money, if they're living at some other place and they want to send money which they owe to some other place, they can just send it in the form of cryptocurrency. Uh, in the initial phases, blockchain was not very popular. People did not realize it in the early 2009, or in fact in 2010. Somehow, when then there were people who were moving from one country to another, and then they realized that they can always transact in form of cryptocurrencies. They started taking payments for their work in form of cryptocurrencies, and all these things happened. And then people realized that they can also store the currency, and as the demand increases, the value of the cryptocurrency will keep going up, and in that way they can also earn it, right? And just like any other currency, any other traditional currency, dollar or rupees or dirham, we know that the currencies have a variable value, and similarly the cryptocurrencies have a variable value as well, and depends completely on the supply chain formula, right? Now, Bitcoin, when it was initially introduced, the sole purpose, as I explained, was to have an exchange of currency. But later on, when people realized that the blockchain is such a technology, it can allow people to use it for other purpose. And then in 2015, there's a guy known as there's a Russian person who was living in Canada. He was just 17 years old. Back then, he introduced another blockchain network known as Ethereum. Now, on top of Bitcoin network, Ethereum had some extra advantages. The first thing, which was very important, and it is still in use in most of the blockchain application, Ethereum is used in order to write some custom logic on top of the blockchain network. And now you cannot just only make cryptocurrency exchanges, you can also build applications on top of the blockchain network. Now, let's say that you have an Instagram. It is made on top of a traditional database, where the database belongs to Meta, which was Facebook in the earlier times, and they have their central database. They store their data with them, and nobody really has access to the complete data. They have it. If they destroy it, it is gone. Unlikely to that, Ethereum allows people to now have custom logic and store the data on a blockchain network, which is again available to a set of people who joins the network and try to validate and keep guard the network, uh, in order to make sure that the data is not rigged. So Ethereum can allow people to write custom logic and build applications on top of it, just like any other application, including Facebook, Insta, or WhatsApp. And when you make a application on top of Ethereum network, it is called a decentralized network. All right. Now, it is called a decentralized application, DAPP, and a traditional application. An application deployed on a blockchain network is called a decentralized application. We will be talking about decentralized application, or DApp in short, in a while as well. Now, um, as I said, original goal was to make sure that there was a peer-to-peer electronic cash system, and then it was used beyond the concept of cryptocurrency in diverse application, including smart contract, decentralized finance. I explained decentralized finance again. The finance part, including the lending, the staking, the borrowing, all these things which were initially just with the banking, were also included in the blockchain um, arena, because we had the option to write custom logics in form of smart contracts, and then we had the currency in form of cryptocurrency, which is the main part of banking system. So we just brought the whole financial system on top of the blockchain network, and this is now very famous, and this is now being used in like a lot of people are now raising money, the companies are raising money in form of cryptocurrencies, and the whole system where the money, the cryptocurrency on a platform is being managed is called decentralized finance. It is a big field, a big platform in itself. There are many people who just work in the decentralized finance space, and it is a very rewarding and very high paying field or platform which can make people realize that other than the traditional finance, decentralized finance is also being used at a similar level in the world nowadays. Now again, one of the most important thing that brought the concept of private blockchain network, we will be differentiating between the public and the private blockchain network in a while, but again, the blockchain is also very relevant in the supply chain tracking. This application or this inclusion comes in because we realize that the data, once we put it on the blockchain, cannot be changed, it cannot be edited, it is immutable, and hence it brings some sort of trust to the people who are basically trading of goods from one place to other, and then there are multiple parties involved. Let's take an example of medical field. If there's a pharmaceutical company making the drugs and it has to reach the retailers, the drug, once it is made in the factory, it goes to the distributor. From the distributor, it goes to the transporters. From the transporters, it goes to the distributors. Then again, from the distributor, it goes to the transporters. From there, it goes to the retail. And while there's a transfer, while there's a supply chain of the drugs, we have to always make sure that the drugs are not changed. It is not being like it is not being used by some fraudulent company to make something which is fake and then being put in these things. And we have to make sure that there's some sort of proof or some sort of picture or something which can validate the originality of these drugs. And blockchain plays a big role in it. We can always use some tag which can only be verified on the blockchain network. And once a retailer receives the product, they can always verify whether it is the actual medicine or the drug which was initially transferred or transported from the factories, right? So blockchain allows us to have these kind of convenience on our table, where we can have the supply chain, uh, like we can track the supply chain, and we can realize whether or not this product which is being supplied is original or not, or if there's some fraudulent activity taking place in between. Again, the last but not the least, digital identity management. People, if you have heard about, like everybody knows about ChatGPT, right? And we know about a company, OpenAI, which made the ChatGPT. And there's a person called Sam Altman. He was the main person who was involved in ChatGPT, and he also has a cryptocurrency. He's also have a blockchain network known as WorldCoin. And what he does there is that he's basically tracing and collecting the data of eyesight, or the uh, eyes of every human body on the planet, and then he's going to use that in order for the digital validation of each and every individual on the planet, whether or not they try to do something online, they purchase something online, they try to play some game online. As soon as you open your laptop, you look into it, you look into the camera, your identity will be recognized. Now this is a very major uh, this is a very major use case of blockchain. We do not know whether the regulation will or will not be taking part in this, and how this will be using this will be used by the big corporation, whether in a good or bad way. But yes, blockchain can help uh, organization or individuals to keep a record in a way that it can always identify people. And the main reason is that the data cannot be changed and it cannot be edited once it is already available on the blockchain database, right? So these are some advantages or some use case that we have. Now we'll talk a bit about the block structure, right? And this is the more technical part of it, and how a blockchain uh, actually functions, right? So a blockchain
Yeah.
is essentially a chain.
Vipul, maybe it's a good time to just pause and ask a question to the students. Or students, if
Right.
there are any questions that you have so far, or anything that you understood or did not understand, who wants to take a moment to share about the learnings from block from so far? Who is that brave heart? In a couple of sentences, that's it. What is blockchain? Yes, yeah, please go ahead.
So blockchain is basically a decentralized way of storing data, um, which is unable to access after it's been stored. So it makes it safer than usual methods of data storage.
Yeah. Yes.
And
Okay.
yeah.
Okay, that is correct. It's just that you can always actually check the data which is there on the blockchain. It cannot be changed, it cannot be edited. Some data can be viewed only by the people who actually own that data, and you do have that leverage on the blockchain. Like you, some people will own their own data, and that cannot be seen by anybody else. But mostly the data is available on the public platform, and you can always view what transactions has been taken place. Is that your identity or the identity of the person who is involved in the transaction is not there. It is just the digital number or the set of numbers and letters there, and nobody knows who is actually the part of that transaction, but you can always see the transaction details on the web.
Fantastic. Dhanesh, you wanted to add something? Yes, go ahead.
Yes, sir. I wanted to ask, what does decentralized applications mean?
Right. So you mean to us decentralized application sums up like the smaller part is DAPP. Now DApp is a very famous word in today's world where people are actually finding an alternative to the uh, companies like Instagram, Facebook, WhatsApp, Twitter, all these things, and they are actually Web3 based applications which are also available, not widely used, but they are already there. Now, what this actually does is that, with the companies like Facebook or Instagram or any other social media company, the data is actually stored on a single server. If we take the example of Facebook, they own the data of Instagram, WhatsApp, and the Facebook. You are not allowed to just go ahead and just ask them to not use your data there, right? And this data is also stored in a raw form. If you have a picture on your Instagram, Facebook has that picture, right? Meta has that picture, the company has it in their database. Now let's suppose that you decide to delete your picture today, right? Or somebody, it happens a lot nowadays. People sometimes upload some bad picture by mistake. You upload it and you then delete it instantly, but the picture always stays with these companies because these are the centralized companies. Now their data is stored in the raw form, like a picture is actually stored in the form of picture. Now what happens is in a decentralized application is that when you have a raw data, let's say that you have some text or some picture, what we do in blockchain is that we convert it into some form of hash by letting it go through an algorithm, and then you have some key with you, and this is a long process in a decentralized explanation application build up. You will have your private key, and then your data is not stored in the blockchain in the raw form. Nobody will be able to see your picture because it has been converted into some numbers and letters using some algorithm. But as soon as you use your private key, when you go into your decentralized application, you open it, and with your private key, it again opens that long string of numbers and letter, and it converts it into the picture. And that power only will you will have because you will be owning that public or the private key that is belonging to just you. Now what that does is that you will be only person who has the access to your picture, and then people who you allow to see that picture. No random company, because there's no central company, there's no central organization which has the hold of the complete data. You are the only person who can decide whether or not you or anybody else can see that picture. So it brings the ownership of the data to the consumers or the people who use that uh, particular decentralized application. Make sense, Tanesh?
Yes, sir. Thanks a lot.
Okay. Is there anything else? Does anybody want to add something? All right. So we'll move on. If you have any question, you can always ask me. We will have some time spare in the end as well. All right. So we will get onto the blockchain structure, right? The block structure in a blockchain. Now, this basically is the technical part of it. We understand how a block is made and what kind of data is inside of a blockchain, right? So as I explained, a blockchain is essentially a chain of digital block that store data, and each block contains transaction data. As I said, let's say uh, A is sending 100 bitcoins to B, then B is sending 10 bitcoins to C, and C is sending 5 bitcoin back to A. All these transaction data, and in the end, what is the final amount? All these things are considered as the transaction data. In form of Bitcoin, if you're using an Ethereum blockchain network where smart contracts are also involved, there you will have different sort of transaction where there's not just the amount of money which is being stored, but all those kind of details which can be converted into cryptographic hashing. Let's say we were talking about the decentralized application, we can have a picture converted into numbers and strings of characters, and we can have this data again stored on the block. Now, the block will have the transaction data. It will have the timestamp. The timestamp is basically the time at which that data is being stored, and then you will have a hash. A hash is basically once you so a blockchain has two part of it. There's a block, the body, and then there's a header. A header is basically the place where you keep the timestamp, and then you keep the hash of the entire block. Now, one block will never have just one transaction, right? We have certain algorithms which is different in every consensus mechanism, which determines the number of transaction that can be there in one block, right? And then according to that, we have some time limit to how long does it take to mine one block and put it on the older blockchain, right? But one block will not have just one transaction, it will have several transactions. And all these transactions, as I said, it is not stored in a raw form. It is used, like the cryptographic algorithms are used to convert it into numbers and letters, and these strings are then stored in the body. And then all these different transactions that has that string, the different uh, thing, the string of characters and numbers, we combine it again, and then we get a final string, and then we put it in the header. Now I will be explaining it to you in the further slides in a better way, so even if you don't understand the complete structure, it is okay. But we have two parts in a block. We have a header, we have a body. The body will have the details of all the transaction. It will have the time at which these transactions were taking place, and the header will have the time at which the block is going to be added to the blockchain and the combined transaction hash. Okay, so these are the two parts. Now, once a block is added to blockchain, its data becomes nearly impossible to alter because every subsequent block depends on it. Now, as I'm telling you, one block will have its own address. The final address will be there. And once you have an address of one block and it is then attached to the blockchain, it will again have the address of previous block added to this block. So once you have a chain of the block, let's say we have the first block in the blockchain network, and it has some block address of the block one, right? So we'll call the it address one. When we add a new block, let's say that is the block two, we will have in the block two, we will have the address of block two, and we will have the address of block one. And then we add the block 3. In the block 3, we will have the address of block 3, and we will have the address of block 2. Now, what this does, at any point of time, even if a single piece of data is changed in any block, the entire block address will change. Now, let's say we have 10 blocks in a blockchain, and let's say some data in the block 5 is been attempted to be changed by some cyber attacker. The block hash will change because the data is changed, everything. uh, Once you, like the cryptographic hashing, it converts the raw data into the string of characters and numbers, as I explained. And once you change the raw data, the algorithm will just change the final string of characters and numbers as well, and that will eventually change the address of the block. Now, once address of block 5 is changed, the address of block 6 will change, because in the block 6 we have the address of block 5, and it will attempt to make some changes in the block 6. And once there's a change in block 6, the address of block 7 will also change. Now there's a chain of changes that happens even if you change one single piece of data in a blockchain network, and because of that it is very safe. Nobody can actually, not the document says it is impossible, nearly impossible, it is actually impossible to change a data which is already there on the blockchain. It is sometimes, it is very difficult, but it is sometimes possible to manipulate or change the data before it is being put on the blockchain, but once it is on the blockchain it cannot be edited or cannot be changed, right? The only problem can be in the consensus mechanism. If there's a faulty consensus mechanism, and now this happens in a lot of scams, people introduce new blockchains which is not perfect, but given the consensus mechanism which is there in the market, which everybody knows, if there's a blockchain network on POW or POS, it is impossible to change the data on a already put on blocked. Now we will talk about a little bit about the distributed ledger. So I believe we understood the part of the hashing the block. As I said, that there's a hash with the transaction, then there's a hash of the previous block. Now this hash is actually the address that I was talking about. Okay. Now let's get to the distributed ledger. Unlike traditional databases managed by the central authority, we already discussed this, but I'll just give you a bit of overview again. Blockchain data is distributed across a network of computers called nodes. Let's say that there's a new blockchain network and you try to join it, you will be recognized as a node. You will not be recognized as a computer. As a computer, which is a part of a blockchain, is called node. Every node holds a copy of the ledger and validates new transactions through consensus mechanism. Not every node is allowed to make the validations, but again, it depends on the consensus mechanism, and who is allowed to validate a transaction is dependent on the consensus mechanism. We have some like the most famous consensus mechanism is POW and POS, and nowadays POH, which is proof of history. Proof of work is what is being used in Bitcoin. It basically gives complex puzzles to the nodes, as I mentioned, people who are the people of the computer who are the part of the network, and the computer which solves this complex puzzle quickest gets to validate a transaction or validate the block and then put it or mine it on a blockchain. Now, the process of putting a new block on the already available blockchain is called mining, and the validators or the miners who validate the transaction then put it on a blockchain are rewarded with some amount. Now Bitcoin miners will be rewarded with Bitcoin, Ethereum miners will be rewarded with Ethereum, Solana miners will be rewarded with Solana. Now the concept of rewards is different in every consensus mechanism. In proof of work, it completely depends on who guesses one random number, and there's a random number approved by the, also when the Bitcoin was introduced by Satoshi Nakamoto, he already had put on a random algorithm which will be throwing random numbers. And that again is dependent on how long it takes the previous block to be mined. And the number is determined, and then the new, when there's a time to add a new block to the existing blockchain, everybody will try to guess that random number. And the peer or the node which guesses that number first gets to basically mine the block, put the block in the existing blockchain, and then they earn the reward in form of Bitcoin. We have a lot of people, we have a lot of countries which have set up their mining farms. We have people setting it up in India. We have some people using solar panels because it is energy intensive. It requires a lot of electricity to guess these random numbers, because this is very random and you cannot actually try to follow some certain pattern. You will have to one by one guess these numbers. It uses a lot of computing power. Now, other than the block of the proof of work, we have proof of stake. Now the Ethereum blockchain network, as I said, it is the second most famous blockchain network out there. It initially used to work with the proof of work as well, but later on there was a realization, because it was consuming a lot of energy or the electricity. the proof of stake was introduced. Now, proof of stake basically allow people who owns the cryptocurrency and then they stake it. Staking means they lock their cryptocurrency onto the network. Now, when they lock their cryptocurrency, they basically um, become the part of the risk that is associated with that blockchain. Now, let's say there's a bank which is operating, and I just put in uh, $1 million in the bank. Now, if the bank is having any problem with if there's a chance that the bank goes bankrupt, then my money will go off as well. Now, with a similar concept, what people with who introduced a proof of stake, what they did, they said that if we want uh, to have some genuine validators on the network, we need to make sure that who has the most stake in that network. Now, people can actually stake their Ethereum currencies. They can lock it on the blockchain network for a certain period, and then they can earn the right to mine the blockchain network, to mine the Ethereum, to validate a transaction, put it on the blockchain network, and then earn rewards in form of Ethereum if they are working on the Ethereum blockchain. Ethereum is not the only blockchain that uses the proof of stake. There are multiple other blockchain nowadays which are using proof of stake, and in each of these blockchain network, the people who are the miners are the people who actually stake their own cryptocurrency. By staking, I mean they lock it for a certain period and they earn the right to validate the transaction on that network. Now, this decentralized structure ensures transparency, security, and mutability. We already discussed about these things. All right, so we'll just have a uh, example of how the transaction take place. Imagine Alice sends one Bitcoin to Bob. The transaction request is broadcast to the network. Now, the network is basically the network of nodes or the different computers. Network nodes validate it using a consensus algorithm. Now, if it is a Bitcoin, it is proof of work. And they basically, there's another thing called as gossip protocol. This protocol is the rule is a set of rule about how the transaction data will be shared among all the nodes in the network, and we will be discussing about this, the gossip protocol, in the later class. Now, gossip protocol allow the transaction to be distributed in all the nodes in the network, and once all the nodes have the transaction, they try to validate it, and then they get to guess that random number. And so they put it in a block, then they try to guess the random number and then put it on the blockchain. And the third point said the transaction bundled into a new block. As I said, there's one block does not contain just one transaction. It has a lot of transaction combined together. Once verified, the block is added to the chain permanently. Verification mean that the transaction will be verified from all the peers, and has to be made sure that all the peers has received the correct information of these transactions. Once it is verified again, it has to be mined using the like the process of POW, where the nodes try to guess a random number, and whoever guesses it first gets to block the mine the block. I'm sorry. Bob receives one Bitcoin once the block is mined and the new block is added to the existing blockchain. It means that transaction is completely verified and Bob receives one Bitcoin. The whole procedure in terms of Bitcoin, it take hardly 2 minutes, not more than that. Now, when there's a congestion, when there's a lot of transaction take place, your transaction will be going on the queue, and it can sometimes take half an hour or even more than that, right? So it depends on the time where when like if there's a lot of transactions taking place at the same time, it does take some extra time to validate and for people to have their transaction go through. All right. So we'll talk about a few applications of the blockchain uh, network. So first of all is cryptocurrency. We have now some currency which we can use to transact just like the traditional currency, but it does not have any foundation. It does not have any regulatory body which allows or de-allows somebody to use it or not. Let's say that you're trying to use dollar to send from one country to another. You would have to go through the banking procedures. You'll have to wait for several days, and then the transaction goes through. In cryptocurrency, it does not matter at all. You can just have one address. Let's say that you're transacting in Bitcoin. You can just receive the Bitcoin address from the person you want to send it to, and then you can just simply send it using your private key. And the transaction hardly takes 2 to 3 minutes. If there's congestion, still it will be done within half an hour. Now, it allows the expansion of the blockchain network reached uh, to the place where we had certain network like Ethereum or Solana. These network allows people to now write custom logic. Custom logic is basically similar to what code we write in traditional way. Let's say that you're using Instagram, it completely works on the code which is uh, the software engineers are writing in the backend. Smart contracts is similar, the same kind of code. It is just that it is self-executing and it is placed on the blockchain. As soon as you try to make a transaction on blockchain, these contracts uses the custom logic and it makes those transactions happen, right? The third example of the application is supply chain management. As I told you that we can always make sure that there's no manipulation in the movement of a product or goods. We can track the products. We can try to find out at what time will it be reaching certain places. It can help us prevent fraud, and it is always transparent because the data is always available on the web, so everybody has the options to go and look at it, right? Now it is used at healthcare because actually this is one of the field where the blockchain is used the most, I would say. In medical field, there's a huge problem of the medical data and whether or not the big corporations or the hospitals should be viewing the data or storing the data of the people, because it helps them charge more money. Once somebody knows that some patient has a major disease, they can sell out the data to the insurance companies. The insurance companies can raise the amount of insurance EMIs that they pay, and that ways there's a whole lobby of corruption that takes place in the healthcare industry. And this blockchain can actually help the patients have the complete control of their data, and then they can only use it when they're going to the hospital, and they can allow the doctors to see their data, or they're going to some pharmacy and they can just go ahead and check what sort of drugs are okay to give to them and all these things. Because once there's a possibility of a person having a private key which can then allow them to use to look into the data which should be belonging to that person only, you can use it in a way where the corporation cannot use your data and cannot sell it to the authorities. They can then take advantages of it. So it is very important in the healthcare as well. Now, in the voting system, because it is transparent, immutable, tamper-proof, it is very obvious that it can be used in voting system, because once you have voted, your digital identity is used to make one vote, and we can make a custom logic that cannot be used to make another vote, and then you just have one vote there. And it is very evident in today's world where we have some sort of corruption in the voting system as well. Even though there's a huge sort of security, and we know that we use algorithms in the regular voting system which cannot allow multiple or double voting, but we know that there are certain kind of fraudulent activities which takes place in the regular or the traditional voting space. So, key elements of blockchain, again, blocks. The block contain data, hash, and the previous hash again is what we were talking about as an address. Hashing ensures immutability. Some hashing algorithms are, as I said, it is SHA 256 or SHA 512. Distributed ledger. Ledger again is a record book where you have a copy of the transaction. Nodes share a copy. Every node or every uh, computer in the network will have the data. So even if it is uh, like one of the computer goes corrupt, you will still be able to fetch the data from the network. Consensus mechanism, there's a set of rules which is being agreed upon in all the nodes of the network upon how they will be following the transaction validations and all those things, and how the reward points will be distributed among the people who are validating those transactions. Smart contracts, again, these are the custom logic written on a blockchain network. These are self-executing code. Once I use, so this is mostly used on the decentralized application, which is again D app. And let's say that you go on a decentralized application, you try to click on something, you try to open a picture. Once you do something, the code activates, it goes to the blockchain, and then the blockchain allows the smart contract to self execute the logic which is supposed to be going on once you make a click. So these are the things which are the main elements of the blockchain and how it enables the entire network.
Vipul, maybe we can just pause again and
Right,
wait for questions.
right, sure,
Or
sure.
yeah, so students, who would any questions here? Are you following? Dhanesh, yes.
Yeah, how does hashing exactly work?
Right.
Okay.
So we'll just talk about the hashing separately from the blockchain network, right? Now, the main purpose of the hashing, and we were talking about the decentralized application a while ago, and we said that if you have a picture and you just want to be the only person who has the access to it and still wants it to be available on the internet, hashing basically is a function, right? If you understand what a function is, everybody has studied function in their mathematics class in the schools, right? Let's say this fx is equal to x squared plus 3x plus 4, right? This is what a function is. Once you change the value of, for different value of x, you will be getting different output for the fx, right? Now, hashing algorithm is basically a function, right? A complex function. Now, once you have a picture or once you have a text data, you can always convert it into random numbers. And then once you have these numbers, you can send it to these algorithms, and you'll have to understand and study how these algorithms work, because this is a completely different subject. But I'll tell you what is the relevance of it. Now, these when we talk about the blockchain, we only use SHA 256 or SHA 512 or similar algorithms. Now, these algorithms are only one-way algorithms. Now, if you have some text, once it is converted into the hash, and when we say hash, it is a hash is basically a long string of random characters and numbers. Okay. Now, these hashes, once you see it with the naked eye, you will not understand anything. Okay. But with your private key, you can unlock these hash and get the original data. But if you do not have the private key, nobody else in the world can actually do it. So these hashes are actually one way. If you have a picture, you convert it into a hash. Nobody can actually convert that hash back into the picture unless and until they have the private key. The private key is always available with the person who is the owner of that data. Let's say if you're using your picture, you are the owner of that picture. So hashing is just an algorithm which converts the raw data into something which looks like numbers and letters, and it cannot be understood by regular people about what exactly that data means. But for somebody who has the private key, he can unlock that hash, and you can actually retrieve the original data from it.
Anna
Understand?
has a question.
Yeah, go
Yeah.
ahead.
What do we mean by self-executing agreements?
Mm-hmm. Okay. So agreements, again, it is we're talking about the smart contracts, right? Now, smart contracts is actually a fancy word here. So we know that when we talk about any application that we use in our phones, let's say we use YouTube, right? Now, YouTube is working on the set of code that the software engineers have written, right? Now, the smart contracts is similar to that. It is just that for the blockchain, the code that we write on the blockchain network is known as smart contracts, just a fancy word. Now, these smart contracts, they are stored on the blockchain. Okay. And when you, let's say that you have a decentralized application, right? And you upload a picture. There's a decentralized application similar to Instagram, and you try to upload a picture, right? The self-executing agreement is something that takes your picture, convert it converts it into a hash, and stores it into the blockchain. And then you can add random data to it. You can index it. You can say that this is the first picture, or this is the second picture, this is the third picture. You can associate tags with it. Okay, I'm going to put it in a red box. So any data that you add on a decentralized application, it is converted into a hash, and then hash is stored on the blockchain. The procedure of converting it into a hash, and what all data should be there, what all data should not be there, if you want to process the data in some additional terms, all these things are like these are executed on the blockchain network by itself, by the logic that we write in form of smart contract. And there's no central authority. And I'll tell you how it is different, and maybe that will make it easier for you to understand. For the regular Instagram, let's say that you have a button, and let's say you have a like button, right? If you double click a picture, you like it. If Facebook, if Instagram decides as today that they will remove that feature, and they will make it for the three taps, and you'll have to click on a picture three times to have a like, it can work, right? But on the blockchain, it is not that way. Nobody can change the data which is already there. So if there's a part of the network where you have a double tap and you can like a picture by double tapping on it, it will be a double tap always. And because it is self executing, it cannot be changed. It will always take place automatically. There's no single person taking care of the server. There's nobody actually looking at what is happening and then executing it. It is all self made, because it is being taken care by the nodes of the network. All they do is sit there and validate the transaction. Now, it is a form of transaction. When you double click a picture, it is a form of transaction. Now, a form of transaction in a way that there's some custom logic written on the blockchain already, and there's a function inside of that logic that is invoked as soon as you make some active or make some action on the decentralized application. They take the action, they execute the logic which is associated with that action. It happens automatically, and then the nodes of the network validate whether or not that action was correct. So the self-executing actions are basically the feature of the blockchain network, where it does not require any third-party person to change or to view or to validate what is going on with your action on a decentralized application. You understand that?
Yes, sir.
Okay. Any other question? All right, so we'll move forward. Again, we will have some time in the end. If you are hesitating to ask the question, make sure that you do not, because the questions, the answers that I give to the questions are actually more specific to the question that you're asking, and the specific explanation can actually make you understand some part of the thing that we are trying to explain, but you might not explain when we are just going through the overview of the entire picture, right? So specific answers can help you in a way that is beneficial for all of you. So if you have some questions, I encourage you to ask them, and we will have some additional time in the end as well. So we will talk about some benefits and the limitations of the blockchains now. So first of all, transparency. I believe we all know how it is transparent, because the data is always available on the blockchain. You will not be able to see who is actually uh, making that transaction, because it is just a random string of numbers. But you will always see what transaction is taking place. For the Bitcoin transaction, you can go to the blockchain.com. For the Ethereum transaction, you can go to ether.io. I'm sorry, ethscan.io. So there are different websites which I've labeled, which shows the details of all the transactions that are being taken place on particular blockchains. Security, again, data is encrypted, it is distributed. You cannot lose the data, because even if one computer is shut down or corrupt, you have the data available with multiple computers. There's no one single server. Data cannot be changed, it cannot be hacked, so it is very secure. It is efficient, because since there's no third party company which is sitting inside, like in form of, in terms of finance, we have the bank, regular traditional finance, we have the bank. They take the transaction, they review it, they check the KYC, all these things. We are able to eliminate it, and we are able to reduce the transaction time and cost because of that. And the traceability, because you know that information which is put on the blockchain cannot be changed later on. You can always go back and see the history of the transactions on a particular network or a particular address, right? Let's say I am making certain transaction. You can just take my address. If you recognize my public address, you can just put it on the blockchain network, and so you'll see all the transactions that has been taken place on that particular address for all the time since the blockchain was introduced. So you have that feature, and you can always trace the transaction. This is very much useful in the land record keeping. Automation, as I said, smart contracts are the self-executing codes. So it works automatically. You do not have to write or get to some write new server logics every time there's some changes. You can always just put the custom logic, write the smart contract, put it on the blockchain, and then when you use a decentralized application, all the logics will be taking place automatically. Again, we have some limitations. First of all, scalability. You have to realize that as the number of transactions are increasing, the cost of the transaction goes up. And as I was telling you, that when the Bitcoin network works, the transaction usually take place within 2 minutes. But as new and more transactions come, plus the transaction goes in the queue and it takes longer time. Again, with the Bitcoin network, we have the consensus mechanism as proof of work. It use people have to guess some random numbers, and this random number can be in millions, right? And we use computing energy to guess this random number, and that uses again a lot of energy, right? Now, Bitcoin mining, or the cryptocurrency mining, is the most uh, energy extensive technology that we have. We do not have any other technology that uses electricity more than this. So this is very big disadvantage. We do have proof of stake, we do have proof of history. We are coming up with other solution that is taking care of these kind of disadvantages. But for now, we do have the most famous blockchain is the Bitcoin, and it still uses the proof of work. Regulatory uncertainty, because we know that blockchain allows people to have transparency, and it does not always it does not actually gives out the identity of the person who's using it or making the transaction. It is being used by the people who are into the crime industry, for the drug trafficking, for many fraudulent activities, for the payments of the crimes, everything. People are using cryptocurrency for that, because there's no identity associated, and people can anonymously send these transactions. It is being used by these bad people, and then there's a requirement of the regulations, so that at least we can recognize the people who are making these transactions. And since there's a very big uncertainty over this, government worldwide sometimes blocking it, sometimes putting some hurdles in the adoption of the blockchain. So these are the disadvantages that we are facing in nowadays. Integration challenges, legacy systems and the businesses may not easily connect to the blockchain platform. So we already have a lot of individual application of the platform which is there, and that is been working for years and years now. And to now just convert everything to the blockchain takes a lot of effort. The whole of the data has to be transferred. You would have to take the uh, permission from the legal authorities and all those things, and these are the challenges which we are facing in the blockchain network and the adoption of it right now. So these are the limitations that we had to discuss. Now let's get to the cryptocurrency. We'll understand a bit more about it. So a cryptocurrency is a digital or virtual currency secured by cryptography. Unlike traditional currencies issued by the government, cryptocurrency operate on decentralized networks. So as we said, we write code for the blockchain, and we write the code for the blockchain. We have to realize that the transactions has to be validated by some people, right? And since we do not have a central authority, just like the banks in a traditional finance, the banks are responsible for validating the transaction. We do not have this kind of validation in the blockchain network. We have the nodes of computer which takes care of these transactions. We have to associate some currency so that we can reward these people for the validation. And with the Bitcoin network, the cryptocurrency was initially introduced not just for the transaction currency, but also to reward the people who validate those transactions. And from that concept, even when we had the Ethereum, where the purpose of that blockchain was not just the exchange of the currency, but it was the smart contract where people can actually make the decentralized application. Even in that space, we knew that we had the space for the validation of the transaction, and we needed the cryptocurrency. So the cryptocurrencies became the very important part of the blockchain network. No public blockchain can operate without the cryptocurrency. A public blockchain is something that has to be validated by certain set of people who uses the consensus mechanism to validate the transaction. There has to be some reward that has to be given to these people who validate the transactions, and the cryptocurrency plays a big role in that, because we can always reward these people in form of cryptocurrency. Now, key features is that it is decentralized in nature. No central authority has a control over the supply or the issuance of these cryptocurrencies. Secured. It is secured, obviously, because we have everything encrypted and the transactions cannot be manipulated. It is being validated by the people who do not know each other already, and they cannot be certain kind of corrupt corrupt society or corrupt set of people who can try to change the transaction. These happens in the traditional finance space but does not happen in blockchain. You do have the global access. You do not need to verify yourself in order to register to a central authority, so you just need internet and a private key. So you have the global access to transfer and transact in these cryptocurrencies, and it is very transparent because your identity is anonymous. The transactions are recorded on blockchain. You can actually see what all transaction has been taken ahead from one particular address, and you can actually go to the very starting and see from the very starting what all transactions has been taking place. Now, the popular cryptocurrencies is Bitcoin, Ethereum, Tether, and Solana. Bitcoin works on the consensus mechanism of POW. Ethereum works on POS. Tether is basically a stable coin. Now, we had to realize that when we are transacting or when we are making the initial purchase of these Bitcoins, and when we decide to trade it, we need some sort of stable currency. And there's a company called Tether in the US. They decided to peg a stable coin with the US dollar. So whatever the amount of USDT they are issuing, they're also keeping the exact same number of dollars with them. And pegging basically means they have mapped it and they're using a digital image of that US dollar onto the blockchain network so that people can actually transact in these cryptocurrencies. Solana, again, Solana is actually an improved way of Ethereum. It uses a different consensus mechanism known as proof of history. It is very high speed. I believe the Ethereum initially when it was using POW, it was able to handle certain some thousand, 2,000 something transaction per second. The limit has increased now as it is going to the POS. But Solana initially introduced 1 million transaction per second, TPS as we call it. When it was introduced, it has not always reached that limit, but it is still very high speed and very efficient in terms of the number of transactions it can process in 1 second. Again, it is very the amount that you have to spend as a transaction fee for every transaction is very low in Solana as compared to Ethereum. All right. So we'll talk a bit about decentralized finance. Now, you know that the entire traditional finance thing, where we have the banks, where we have people having their fixed deposits, their people are lending money, they're taking loan, they're purchasing stuff on EMIs. All these things are enabled and they are into the practice because there's a central authority which allows the functioning of the money. And where there's money, there's again the applications of money, and the regular application of money include the lending or the borrowing or the loans or the EMIs and everything. And since it works on the traditional finance, the exact same thing works on the regular decentralized finance on the blockchain network as well. And you can use your cryptocurrencies to basically, you can borrow it, you can lend it to some other people, you can have some collateral associated with your currency. You can lock it and earn interest on it, just like the fixed deposit or the savings or the other sort of deposit that you make to the bank pays you in form of interest. You can do the same thing in the decentralized finance as well. As I said, the decentralized finance itself is a very big industry. It is an industry in itself, and there's a lot of people making a lot of money in this field. Now, it allows lending and borrowing. It allows decentralized exchanges where people can actually trade every now and then. Some of the famous decentralized exchanges are Trust Wallet or SafePal or MetaMask. Then there are centralized exchanges as well, known as Binance or Coinbase. These are the exchanges which allows you to purchase or exchange these currencies in order to get some different currencies. If you want to trade, you want to earn a reward or make money by trading, these exchanges can help you. Now you can yield farm, you can stake. Now these are the terms which are associated again with the same kind of banking that we do in a traditional way. Staking means locking, yield farming means you basically go ahead and continuously lock your coins and then earn reward, and then do the reward that you earn, you use it in order to lock some other currency, and then by locking one currency you earn some new currency. All these things are available on the decentralized exchanges for you to go through, and if you do it in the right way, people are making some good money through this. Not always, it is very risky, but still there's an option to basically trade and make money through this. And then there's a concept of stable coins, as we were talking about USDT Tether. It was pegged to the US dollar. It was the digital form of the US dollar, and you do not really need to spend it through some banking application, or you do not need to spend it through in the form of cash. You can always use the blockchain to just send this money. And since it is pegged to a fiat currency means the regular traditional currency that we have, dollar, rupees, dirham, or anything. And because it is pegged to a regular currency, the stable coin, if I'm sending you the tether, the USDT, if I'm sending you 2 USDT, you can always get $2 in form of those USDT, and you can sell it to the US government through the exchanges that is there on the platforms. So it is stable coin. The value of stable coins does not change, and it is actually changed according to the traditional. So let's say that you have USDT which is pegged to the dollar. If the value of dollar is going up, the value of your stable coin or the USDT will go up. If the value of dollar is going down, the value of your USDT will go down. So it matches the value of the fiat currency. User can deposit crypto in a DeFi protocol like Aave or Compound and earn interest directly from the borrowers without any bank involved. Again, this is a form of deposits that you can make. This is one simple example. You can lock your currencies. You can like have a fixed deposit. You can have a deposit for a shorter time, and you can have multiple protocols working for in order to earn interest. Or sometimes if you want to borrow some currencies, you can do that too by paying certain extra amount when you decide to buy it, right, or borrow it. Now we will just talk about this one big use case, and we will have some assignment, as I said, as Devesh explained in the starting. We will be giving you some assignment that will be useful for your understanding. So, and for that, it is important that you understand this particular example well, right? Now, supply chain is actually the most used uh, real world use case of blockchain in today's space. And I'll give you again the same example of how drug medicine is. Once it is made in a factory, it has been associated with a digital stamp on their, or you can say a QR code or a barcode uh, on their medicine pack. And then these medicine pack are being transferred. And as soon as I'll just give you a complete, you don't have to look at, you can look at, but you don't have to at the diagram, but I'll just give you an overview of how this one particular example uses the blockchain in order to make sure that there's a transparency in supply chain, how it is efficient for people to uh, trace it with the entire supply chain. So let's say that there's a company which has a factory, and they're manufacturing drugs, and they have to eventually send it to the pharmacies or the retailers who send it to the consumers eventually, or the patients eventually. So you make the drug and you initially send it to the distributors, right? And it has to be sent to the distributor through some form of transport, right? Now we have, if we have a decentralized application where the people from the factory, as soon as or they dispatch the drugs, they can update in that decentralized application with all the barcodes and all the numbers and all the timings that they have sent the drug, with all the identification of the transportation vehicles, everything. You have starting point where all the details of that uh, supply is being put, and then only the people who are there, the part of the supply chain. Now the people who can be the part of the supply chain can initially be the factory, then the transporting company, then the distributors, then again the transporting company, from the distributors to the retailers, and then the retailers. And all these people can have access to one decentralized application. They will be having their one digital identity, which will be giving them different sort of access. Now let's say that the retailers will not have the access to the maybe the kind of formula that the factory is using, but the factory and the scientists who are in the factory will have the formula of the drug. So we can actually decide who can have, through which identity or through which private key one can have different access solutions to different information which is there on the blockchain. And through this you will know that the update, so let's say that once the drugs is dispatched from the transportation, it takes about 1 day to reach a location. Throughout that day, the transportation company will be updating on the blockchain about the geolocation of that, the temperature at which it is being kept, the outside temperature, what kind of environment they are running their vehicle, and everything can be updated on the blockchain. And the complete environment of the people who are using that decentralized application will have access to that information. Now what this does, it basically brings down the possibility of fraud, where with a company who basically manufacture malicious drugs or the fake drugs, they cannot actually sneak in and have a part in this supply chain, because now everything can be monitored by the all the stakeholders in that network, right? So this is a very important, very uh, this is the most used usage or the use case of the blockchain, along with what we see in the medical industry. What we see here is the cooperation of multiple stakeholders, and because we know the data cannot be changed, we know that the supply chain information, the data can always be accessed by all the stakeholders. Similarly, in the medical field, we know that the one entity, one person can have the complete control of their data, and then they can choose when or where they want to show that data, and then take advantage of that data, right? And then the big corporation does not have to store your data. They are not the complete owner, they cannot misuse it, they cannot sell it to the other companies. All these things are the use cases that we are already into in 2025, and certainly we are going to have a lot of new use cases coming through. And there are a lot of companies who have been into the research. There are people who are in doing phd in blockchain, or in some particular domain they are going through these different understanding where they can apply blockchain as a solution. And your next assignment is going to be related to that. Now we will have to see what will be the situation, the scenario, where the blockchain will be used from 10 years from now. So I
Yeah.
want all of you, yeah, go ahead.
Go ahead. No, go ahead with
Right. So I just want all of you to have your own research, go through some documents that are already there on the web, see how the blockchain is changing or revolutionizing the world of usage on the digital platforms, and understand what are the future opportunities that we can have in the next 10 years. Make a complete report on it, and we will be reviewing that. As Devesh explained, your peers will be reviewing it initially, and of course, I will be reviewing it too.
So I will send you a Google form, everyone, using which you'll have to submit your research, your report, and then your submissions will be shared with other students. They will peer review your work, and you will review someone else's work. And in the end, Vipul will share his thoughts and insights with everyone. So this.
So we should allow the students to have some questions if they want.
Yes,
Yeah.
let's, yeah, please feel free to unmute yourself, ask questions, share your thoughts, insights. Students who have not yet asked, I encourage them to ask as well. It's a good opportunity to, uh, it's a very small group, students, so don't hesitate. It's an opportunity to ask anything that you would like. Okay. And no question is a stupid question. Please understand that. And the question on your mind is also there on someone else's mind. So just ask it. Okay. Just ask. Raghav, you are away for a minute, but what I'm going to do is I'm going to send everyone a Google form with the assignment, which you need to submit by 5th of November. And then your work will be reviewed by another student. It's called peer review, and another student's work or submission will be reviewed by you. That is to be done by 7th of November. And then we'll meet again on the 9th for the closing session, where we'll go deeper into the topic, and we'll sort of discuss your submissions as well. Okay.
Okay.
Yes, everyone. Questions?
Is there any format or something for the report?
So the in the Google form, there'll be a space where you need to write a 500-word report, and there has to be a header or a topic or a subject to it, and then the 500 words can be broken down into points or paragraphs. That's up to you. Yeah. But there are some and let me very quickly actually show you the question so that you'll have an idea. Just once again. I'm sharing my screen now. This is what the question will look like. Okay. Future of blockchain in everyday life, a scenario from 2035. In 2035, blockchain technology will look very different from what we know today. For this mini project, imagine a day in life of an ordinary citizen who interacts with blockchain-enabled systems without even realizing it. Now, you need to write a 500-word analysis or a report that covers a real-world problem in any of these fields and that uses blockchain. Explain a future blockchain-based solution in your own words. Show how a user will experience it and how they will interact with the system. And then what could be a limitation or risk of that system. And then give one practical idea from your own imagination. See, first you make this by yourself. Don't simply focus on chat GPT or AI tools to build this. First, you work on it by yourself, and then just for formatting or for editing, you can use chat GPT. But don't use it completely, because then you are not doing justice to this, and you are just not being fair to yourself. Yeah. Please be fair to yourself. Put in your time and efforts and write it by yourself. Okay. Email, name, title, and your submission. Yeah. 500 words. Okay. Make sense, everyone? Yes. By 5th of November, you will need to submit it. I'm going to send you today's recording of our previous masterclass. We did another masterclass last month, and then I'm going to send you the link for this particular form, Google form. Yeah, everyone. Okay, great. Let's if there are questions, quickly ask them.
Please,
Yeah.
if anybody has any question, you can surely ask.
Is it safe to lend and borrow money on blockchain without any central authority?
See, you can actually not lend or you cannot actually not lend or borrow or do anything without a central authority to be starting with. How will you purchase a cryptocurrency? Initially, you will have to be a part of the central exchange, right? In India, we do have the CoinSwitch Kuber or CoinDCX. I do not recommend these things as of now, because these companies, India does not have a very good regulation system right now, and these companies have been taking advantage. A lot of people have lost a lot of money through the Wazir scam that happened, and there are some other ways to make take the cryptocurrencies. But if you even if you want to actually get the cryptocurrencies, you can use these exchanges, CoinDCX or CoinSwitch Coupe, and then when you have the cryptocurrencies, you can always send it to the decentralized exchange. Now these are the centralized exchange, and you do have the option to send it to the uh, from the centralized to the decentralized exchanges. However, when you get the money back on your centralized exchange, if you want to sell it, the government is going to get after you, and they will be asking you to prove where you did what, and you will have to eventually show everything to the government, right? So you'll have to always keep in mind that you're doing everything legal. As soon as you're doing everything legal and you can share the documents of what you're doing and the proof of what you're doing, you're always on the safe side. But yes, if you want to trade or do something, initially you'll have to get into some centralized exchange, make the purchase from there, get the cryptocurrency, send it to a decentralized exchange, and on the decentralized exchange, you can do whatever you want. You can trade it, you can try to stake it, you can lend it, you can borrow it, whatever you want to do.
Thank you.
Yep. Any other question?
Yeah. What's the difference between USD coin and USD Tether?
USD coin. Okay, so these are just the two different companies. USD coin, you mean to say USDC, right? USDC is a coin which is actually introduced by a company called Circle. So in US, there are two companies which are dealing with these two major stable coins. There's one company called as Tether. Tether actually introduced USDT. Again, the name of the coin is again the Tether. The USDT DC is the USD coin. It works in the exact same way. They just have some different algorithm in the background, but it is both the coins are actually pegged with the US dollar. As the price of the US dollar goes up, the prices of these both stable coins goes up, and if it goes down, the US dollar, then the prices with the USDC or the USDT will goes down as well. They are very similar in how they function on the blockchain network. They're both stable coins. Yeah.
How does the price of USDC remain around $1?
So how does it remain around $1? Because it is pegged with the US dollar. A US dollar, $1 is always going to be $1, right? But how you determine whether or not like the value declines with the declination of the value of the US dollar is like uh, it is always relative, right? When you're trying to understand the value of dollar, let's say that value of $1 is always going to be $1. But let's say that Indian currency, let's take an example of INR, Indian rupees, right? If Indian rupees and Indian economy is doing good and we have a trade deficit, which is again far from possible in today's time, but it will take place at some point of time. But if we have a trade deficit and our currency gets stronger and there's more confidence in rupees rather than dollar, for now, if you see the $1 is equal to 88 rupees, around something like that, the value of that will go down, right? Maybe the $1 will come back to 65 or come back to 50. Now that's degradation of dollar. That means that the value of dollar is going down. Now $1 is $1, one USDT is going to be one USDT. But now if you try to convert USDT into the rupees, instead of 88 rupees, you'll be getting 65 rupees, right? So that's the degradation of dollar. The value of dollar in terms of Indian rupees has gone down, right? The stable coin, just peg it with the dollar. $1 will always be $1.
Yeah, but the trading always happens on USDC.
See, the trading happens on the USDT. You will be staying in India. You will be withdrawing the money if you want the money in your hand at the end of the day. For now, because the stable coins are not the coins that are being used everywhere. If you want one cryptocurrency that does not change the value, you will have to bring it into the currency that your country accepts, right? Having said that, if you're using US dollar, people what they do is that, let's say that the market is really down, you think that the market is going to be very volatile and you don't want to trade in the cryptocurrencies at least for next 6 months, you can keep the money in the form of USDT, right? It means that you have $1, the value is not going to change and you're not going to lose any money. But what if eventually you'll have to money, you are initially from India, you will be investing the amount in the form of Indian rupees, right? You don't have access to dollar or any other currency. Initially you'll be investing in rupees. This again is same for people from different countries as well. They will be investing in the currency that their country helps them with. And if that currency, let's say you are holding USDT and the value of USDT goes down, when you will be converting that back into the fiat currency that your country supports, at that point of time you will realize that the amount of that, the exchange rate of that currency has gone down. So that is what happened when the currency is going down. uh, but yeah, that is it. Is there anything specific that you want to know how the USDT work and how you will always have this trade? So the reason we have USDT at the place at the USDC at the place is because the dollar is the one of the currency which is uh, the strongest, and it is strongest because the US economy is the people put most confidence in it. We know if in today's world, if the economy is going down, the US will be in the end, right? They have very big military, they can protect themselves, and they are not going to have such major issues with their economy. So that's the reason people trust US dollar, and that is the reason people are actually trading. Depends on the people. If you want to trade in USDT, you can trade in USDT, no, but there's stable coin for the euro as well. People are not using euro as a regular trade currency, because they know that the euro is less stable than the US dollar, right? And that is the reason they use US dollar in most form of currency, and that is the reason these stable coins, which are pegged with the US dollar, are most used in the trading platforms or on the trading platforms where you trade in the cryptocurrencies, right?
Yes, thanks.
Any other question?
Perfect. I think it's time to close. Expect my email in the next couple of hours. In the email, you'll find details about today's recording of a previous masterclass, and the link to submit your assignment. Once everyone has submitted their assignments, I'll share a peer's assignment with you, and I'll provide you, and you will need to provide feedback on your peer's assignment. Make sense, everyone on board with this? Yes? Can I see a thumbs up like that? Okay, perfect. Super. Great. Thank you so much, everyone. We'll see you next Sunday, same time. But before that, over the next 3 to 4 days, you have work to do. Yeah? Complete that on time. Don't be late. And the next session we'll start on time, just like we did today. Join 5 minutes early. Yes? Perfect. Good luck, everyone.
See everyone.
Thank you.
Thank you. Bye.